So imagine this. This is a tetrahedron formed by this plane over here, this plane in front, and the coordinate plane. So the XZ plane, the YZ plane, and also the XY plane. So that's the tetrahedron. So we try to find the value of this. So I think it's better that we should write down the solid right there, the E. So let's represent that solid E there. So the solid E is the set of all points X, Y, Z, such that, let's see what happened to each one. I think this is the most, that's the most important part. Once you can figure this out, then the integral will follow. So let's try to figure this out. Now, looking at this solid here, looks like it is a Z type, right? As you mentioned that,
yes.
you gave it me. It's a Z type because the Z has bounded below by a surface and bounded above by a surface. So it's a Z type. So let's get that Z here and figure out it's bounded below by what, bounded above by what. So looking at this tetrahedron, so it's bounded below by this XY plane, which is Z equal to 0. 0. Yeah, so you got it. So 0. And then above by this plane right here, right?
Mm-hmm.
So so the way that you think about it is this. You think about the Z, right? You can try to draw, maybe you can try to draw some line. Let's say some line over here, this, and then you say, well, where does it go? Well, it has to go, you can't go over this ceiling. The plane over there is a ceiling. So it's from the XY plane and you go up. As soon as you hit the plane right here, then it's going to stop right there. So the Z is going to go from 0 all the way to whatever the coordinate here when you hit this plane right there, right?
Mm-hmm.
So now if you have another one, now for example, this point over here, this is origin. If you go up, it's going to hit this point over here and stop. And if you have other point, for example, this point here, it's going to hit maybe some graph right here and stop. So they're going to stop. Think about it's like a glass ceiling. So this plane over here is like a glass ceiling. So the Z can never go beyond this plane. If you go beyond this plane, it will be outside here. That's not inside the tetrahedron. So this plane here is it's kind of like the glass ceiling for this tetrahedron. So the Z can never go beyond that one.
Okay.
So if I wish I can rotate this, maybe I just draw it there. If you rotate this, okay, and then we have this, so this is X and this is a Y, and then this is the Z over here, then you're going to see that it's going to like this, right? So, and if you're looking at this plane over here at this angle, so this is the plane right here we have, which is the one that we have over here, the yellow one. You see the Z actually go from the XY plane, and then as soon as you hit the plane, it's going to stop. So every point over here, I hit the plane and stop right there. So the upper limit for the Z will be, the Z is going to be bounded above by this surface right there.
Okay.
Yeah?
Yes. So you solve for Z on the.
So yes, you got it. Solve for Z. So Z is equal to 4 minus 3x minus 1. So you have 4 minus 3x minus 1. Okay, so we figure out the Z. Okay, and then now we can go to the Y. Let's look at the XY plane. On the XY plane, is that one right there. So this is X and this is a Y plane, and that is going to have the green one right there. Let's say it's this one right here. Okay, and whatever this, and then this one over here is this one right here. So it's going to be a triangle like this on this XY plane. You can actually think about either type 1 or type 2, right? But which one easier? Whichever is easier for you.
Type 1, I think, is easier.
Let's make it type 1. I think might be easier. Then you need to get the equation for this line over here. Okay, what's the equation for this line? Well, this line over here is where this plane over here intersect with the XY plane, right? So Z will be equal to 0.
0, okay.
Yeah, so we're going to set this to be 0. Set this to be 0. Then you will have 0 equal to 4 minus 3x minus y. In other words, this is, if you solve for y, this is what? Y equal to 4 minus 3x. 4 minus 3x, right?
Yes.
So you put it that way. So we have that one. So the green one is, the green line has this equation. That's the equation for that one. Okay, now we also need to get the below one, which is this one right here. Oh, that one is easy, right? That one,
yes.
y is equal to what?
Y is 0.
So, yeah, y equals 0. So, and remember for that region, you draw the arrow, right? From
Yes.
below to above, like that. So this is a type 1. So it is type 1 region. Okay. So the y here, the below one, and this is above one. So we can actually represent this. So we have y here. You can also call the type y in this one, in this region. So y go from 0 to 4 minus 3x. 0 to 4 minus 3x. Okay. Finally, we can get to x. X go from, now you look at the region, this region here, down on the xy plane. So x go from what to what? It go from 0 and then to this point. How do you figure out that point then? You will set
That y
y equals 0. Set y equals 0. X is 4 over 3, right?
Yes.
You get 4 over 3 right here. So it will be 0 and 4 over 3. Now, once you get this solid here set up like this, then the integral will be easier to set up. So let's do that. So the value for this tetrahedron is the triple integral of 1. Remember, when you integrate 1 over the solid, you get the value, right? Okay.
Yes.
Okay, so we're going to set this up. Now this one, definitely we had to use not the polar because it has no circular. So now we have, with 1, you don't need to write a 1 there. So let's just put that down. The innermost one has to be this one, the z one here. So it has to be dz. Okay, so dz here in this case. And then the next one here, this one, y expressed in terms of x. So it will be that one. So it will be dy. And then the last one will be this one. So it will be dx. And now we just put the corresponding limit of integration. So g go from this to this. So it go from 0 to 4 minus 3x minus y. And then we know the y go from 0 to 4 minus 3x. Okay, so 0, 4 minus 3x here. And then finally, x go from 0 to 4 over 3. So 0 to 4 over 3 here. So we set up the integral and the rest over here will follow after you do this. I think setting up is the most difficult one. Yeah.
Yes.
This one here, I think that might be a formula. Tetrahedron, right? It's 1/3 the base times the height. So in this case, if you use that formula, it's going to be 1/3 the base area times the height. So in this case, the base here is actually, the base is this one. This is the base. This is the base. So it's the base area right there. And then times the height. So 1/3. The base with the base area over here is 1/2 base times height. So it's 1/2. This is 4 over 3. The height here, when x is 0, y is equal to 4. So times 4. And the height over here is z over here. So when x and y equal 0, z is equal to 4. So the height is 4. So the answer here should be, it is 32 over 9. And if you try evaluate this integral, it should actually equal to 32 over 9 also. Yeah, we can verify that. Okay. All right.
Okay.
Should we finish it? Maybe we should finish this.
Okay.
Okay, let's do the innermost first. Okay. So let's do the innermost one first. So do this one over here. It's gonna give you
Z.
this upper limit subtract this limit, this one, because you're integrating 1, right? Remember when you're integrating 1 dx, x go from a to b.
Yes.
That is just b minus a. integrating here will be this subtracting this. So that will be 4 minus 3x minus y. So you get 4 minus 3x minus y here. So that innermost integral will become this. Now we have dy, dx. Y go from 0 to 4 minus 3x. X go from 0 to 4 over 3. Now this is 0 to 4 over 3. The antiderivative is with respect to y. So that will be 4y minus 3xy minus y squared over 2. And then we go from 0 to 4 minus 3x. And then dx over here. Let's try that. So substituting 4 minus 3x over here. Let's do it on the side. So you have 4 times y is 4 minus 3x minus 3x times 4 minus 3x. There's a lot of algebra.
Yes, it is.
4 minus 3x over here square over 2. So that will be, oh, actually, we can take out this common factor 4 minus 3x. Then you will have 4 minus 3x times 4 minus 3x. So this 2 is actually 4 minus 3x squared.
Oh, yeah. And then
Minus 4 minus 3x squared over 2. That will be 4 minus 3x squared over 2. Right?
Yes.
So, yeah. So, which is going to be, so let's just enter that over here. Okay. So we have 4 minus 3x squared over 2 dx. X go from 0 to 4 over 3. This one here, I think maybe we should expand that so that we can integrate chain by chain. If we expand that, what do we get? We should get 16
minus 24x.
24, yes, x plus 9x squared, and then all over 2. So that will be 8 minus 12x plus 9 over 2x squared. We have this, which is equivalent to that. So we're going to take antiderivative of each term. So we should get 8x minus 6x squared plus 9x cubed over 6, which is 3, 2. And then go from 0, 4 over 3, right?
Yes.
Now you can actually use a calculator or whatever to evaluate that. And that should be equal to 32 over 9. Should be the same number that you have over here. Okay?
Okay.
Yeah. I think the hardest part is to set it up. Once you set it up, the rest will come